Okay, question 15, the final question, we're almost there. So we got some probability. So, a sample of 200 households was taken in a small town. Each household was asked to complete a questionnaire about their purchases of takeaway food. A is the event that a household regularly purchases Indian food. B is the event that households regularly purchase Chinese food. Now we're talking. It was observed that the probability of B given A was 0.25 and the probability that A given B was 0.1. Of the households, 122 indicated that they do not regularly purchase Indian or Chinese food. A household is selected at random from those in the sample. We want to find the probability that this household regularly purchases both Indian and Chinese food. Okay, so first up, let's start with what we want to try and find. So we want the probability of A intersection B. Okay, so before we get into the formulas, what else do we know? Well, we know that A union B is 200 minus 122. So households that regularly purchase Indian or Chinese is 200 minus the ones that don't regularly purchase either one. So that is 88. No, it's not. That's 78. So the probability of A union B is 78 over 200, which is 39 over 100. Okay, now in the formula book we are given these two probability formulas. Now both of them are going to be very useful for this question. Okay, so from the first one then, the probability of A union B is probability of A and probability of B minus the probability of the intersection. Now we know the probability of A union B. So we're going to write down 39 over 100 is equal to the probability of A and the probability of B minus the probability of the intersection. Now, we know that the probability of B given A is 0.25. So, as a fraction, probability B given A is 1/4. Now, using the second formula, we know that the probability of the probability of A intersection B in terms of B given A is the probability of A times the probability of B given A. So that's times a quarter. So from that, we can get that the probability of A is 4 times the probability of the intersection. Now if we do something very similar for A given B, so we were told the probability of A given B was 0.1, which, let's keep it as a fraction, is 1/10. So here we can say the probability of the intersection is equal to the probability of B times the probability of A given B, so times 1/10. Now this gives us that the probability of B is equal to 10 times the probability of the intersection. So, now that we know what probability of A and probability of B are in terms of the intersection, we can go back to our union equation. So we now know what the probability of A and the probability of B are in terms of the intersection. So, now we know that we've run out of room, as always. Okay, so now we know that 39 over 100 is equal to P of A, but we now know that P of A is 4 times the probability of the intersection, so we have 4 lots of that. Add the probability of B, which was 10 times the intersection, minus 1 lot of the intersection. So on the right we've got 13 times the intersection is equal to 39 over 100. Divide through by 13 and we get the intersection probability is 3 over 100. Yay. Okay guys, that's the paper done. I really hope you found this useful. This has taken ages to do. I really hate statistics, to be completely honest. If you're watching this in 2019, then there were new spec papers in 2018, which I'm going to go on and do right now. Take it easy guys, take care.